Okay, so good day to our grade 8 Math and Science High School students. We're going to continue our discussion on for the third quarter. Okay, for our lessons on the third quarter. So this is going to be our lesson. This is going to be our 7th lesson. Okay, and this is on trigonometry. Introduction to trigonometry. Okay, so we have special right angles and trigonometric ratios and their applications. So let's try to answer this question. Okay, letter B. A road is to be constructed so that it will rise 105 feet for each 1,000 feet of horizontal distance. So find the measure of the angle of rise to the nearest degree and the length of road to the nearest foot for each 1,000 feet of horizontal distance. Now, what would this look like if we're going to draw it? We're going to try to illustrate it here on our board. So we have here, it says here that this road is going to rise. So that means it kind of looks like a ramp. Okay, if you've seen like a skateboard ramp or anything that has a slope on it, so it kind of looks like a ramp. So let's try to construct that. Okay, just a minute. Okay, so let's try to make that here. Okay, so it's gonna rise 105 feet. And then it has a horizontal distance of 1,000 feet. So it's kind of like 1 kilometer. Okay, so this is, let's say for example, our horizontal distance. Okay, so it's not to scale. Okay, and that means it's gonna rise here. Okay. And let's assume that this road is at vertical angles with the ground. Okay, so what are we trying to find? We need to find the length of the road. So if this is the slope or the ramp where the road is on, so the road should be like here. Here it goes. So there's a road, and we need to find its length. What's the length of this road in feet, and what is the angle of the rise? So we have a term for this, the angle of the rise. If we have an observer here at the bottom, so the angle of the rise from his point, okay, let's say he's here, or more appropriately, he's at the start of this road. So we have this term for the angle of the rise, so we call this the angle of elevation. Okay, the angle of elevation. Okay, for this problem. Okay, so for this one, what is the angle of the rise and the distance and feet of the road? So for the easiest or the first value that we can find for this problem would most probably be the length of the road to the nearest foot. And what would that be? Since we're given 105 feet as our as one of the sides that was given in this problem, and then there's another given 1,000 feet, and this is a reference angle. Okay, so let's name it as theta. Okay, so theta, the Greek letter theta. So let's try to pick. Let's try to pick out of the three trigonometric ratios. So we have so, ka, toa. Which of these three will we use to solve for the missing side measurement and also the missing angle measurement? Okay, since we have here theta, and theta is, okay, so it's facing here, and it has an opposite side, so that means we could use so and toa. We can't use ka anymore because your theta over here has an opposite side, and this theta here has an adjacent side. So both requirements or both prerequisites were met by the toa trigonometric ratio. Most likely we will have to use the toa trigonometric ratio. So that's tan theta, okay, and that's gonna be equal to the opposite side, which stands for O, and then the adjacent side, which stands for A. So therefore we have here the opposite side, which is 105 feet, all over the adjacent side, which is 1,000 feet. And that's equal to tangent theta. Okay, so for this problem, we're going to solve first for theta, since we're given here the two side measurements. So theta is going to be equal to the inverse tangent. Okay, so that's tangent raised to negative 1 of 105 divided by 1000. And if you try to put that on your calculator, so what would that look like? Okay, so that would look like, okay, tangent, the inverse tangent of 105 divided by 1000. So what would that look like? So it's gonna look like this. Okay, so if you have your calculator, I think hopefully you guys can see it on the webcam. So that's tangent raised to negative 1. Okay, open parentheses 105 all over 1000, close parentheses. Okay, and that should give you an angle of 5.99 degrees, or approximately around 6 degrees. So therefore the angle of the rise, therefore the value, okay, so wait a minute. So therefore the value of the angle of rise, or the angle of elevation, is 6 degrees, approximately. And how do we find the length of the road? So since this is a right triangle, and we're given two sides, most likely if we have right triangles, we're going to use our favorite theorem. So that's the Pythagorean theorem for this problem. So we have here 105 squared plus 1000 squared. So that should be equal to c squared, where c is r, but c is the length of the road. Okay, so c is the length of our road. So to solve for c, let's try to simplify our given problem. So we have 105 squared, okay, plus 1000 squared. So that's gonna give us a big number. So it's a very big number. So this is 1,011,025. Okay, and we have to take the square root of this very big number in order to find the value of c. So what's the square root of 1,011,025? So that's around 1005.50. There you go. So therefore, what's the length of the road? So the road is actually 1005.5 feet, or just 5.5 feet more than the base, or the horizontal distance from the tip to the edge of the rise of the road. Okay, so also approximately like 1 kilometer. Okay, so we're able to solve both problems out. So the angle of the rise is 6 degrees, and the length of the road is 1005.5. Okay, and that's how we solve this trigonometric ratio